Hello, in this lecture we will find the radius of a circle enclosed in a triangle. As you can see in the drawing, we have triangle ABC. Side AB of the triangle equals to 4 units, side BC of the triangle equals to 3 units, and side AC of triangle ABC equals to 5 units. And we also know that the area of triangle ABC equals to 6 units squared. And inside the triangle we have a circle, and we want to know the radius of this circle. First of all, we will define the center of this circle as O. Okay, point O is the center of this circle. Then we will define the touching point between side AB of the triangle and the circle as N. Again, the touching point between side AB of the triangle and the circle is point N. And actually we can also say that side AB of the triangle is tangent to the circle at point N. We will also define the touching point between side BC of the triangle and the circle as M. I will repeat again, point M is the touching point between side BC of the triangle and the circle. Or we can also say that side BC is tangent to the circle at point M. And then we will also define the touching point of side ABC of the triangle with the circle as P. Again, point P is the touching point between side AC of the triangle and the circle. Or we can also say that side AC of the triangle is tangent to the circle at point P. Okay. In the next step, we'll connect together points O and N by a straight line. Actually, line segment NO is the radius of this circle. I will mark it as small r. And the reason that line segment NO is the radius of this circle is because it starts from the center of the circle, that is to say, it starts from point O and ends at point N, that is a point on the circle itself. For that reason, line segment NO is the radius of this circle. We will also connect points O and M together by a straight line. And again, line segment MO is the radius of this circle. I will mark it as R because of the fact that line segment MO starts from the center of the circle, that is to say from point O, and ends at point M, that is a point on the circle itself. It is defined as the radius of the circle. We will also connect together points O and P by a straight line. Again, line segment PO is the radius of this circle. I will mark it as R because it starts from the center of the circle. That is to say, it starts from point O and ends at point P, that is the point of the circle itself. For that reason, line segment PO is the radius of this circle. Okay, so actually we created three radiuses, and we have three tangents to those radiuses. Side AB is tangent to the radius at point N. Side BC of the triangle is tangent to the radius at point M, and side AC of the triangle is tangent to the radius OP at point P. Okay, and we actually have a rule. I will call it rule number 1. According to rule number 1, in any circle, a radius and the tangent to that radius are perpendicular to each other. So I will read rule number 1 again. Rule number 1 states that in any circle, a radius and the tangent to that radius are perpendicular to each other. So actually, if we have a radius, let's call it R, and we have tangent to that radius, let's call it T. Then the radius is perpendicular to the tangent. That is to say, this angle is 90 degrees and this angle also equals to 90 degrees. So in any circle, a radius is perpendicular to its tangent. Okay, so actually we can implement rule number 1 in our circle, because we have in our circle line segment NO, that is the radius of this circle, and we have the tangent to this radius, that is side AB of the triangle. And according to rule number 1, the radius is perpendicular to its tangent. That is to say, angle ONA equals to 90 degrees, and also angle ONB equals to 90 degrees. Okay, in the same way, line segment MO is the radius of this circle, and we have tangent to this radius. Actually, side BC of the triangle is tangent to this radius. And for that reason, according to rule number 1, the radius is perpendicular to its tangent. That is to say, angle OMB equals to 90 degrees, and also angle OMC equals to 90 degrees, because the radius is perpendicular to its tangent. That is to say, this angle is 90 degrees and this angle also equals to 90 degrees. And in the same way, line segment OP is the radius of this circle, and we have the tangent to this radius. AC is tangent to this radius. For that reason, according to rule number 1, angle OPA equals to 90 degrees, and also angle OBC equals to 90 degrees, because the radius, this radius is perpendicular to its tangent AC. For this reason, this angle is 90 degrees and this angle also equals to 90 degrees. Okay? And we actually have a general formula for the area of any triangle. The area of any triangle equals to the base of the triangle times the height to the base divided by 2. Okay? So the formula for the area of any triangle equals to the base of the triangle times the height to the base divided by 2. And you should remember that the height to the base must create angle of 90 degrees with the base. Okay, again, the height of the triangle must create 90 degrees with the base. Okay, and instead of area of a triangle, we can write capital A, that is abbreviation for area. So the area of a triangle, that is A, equals to the base of the triangle times the height to the base divided by 2. Again, the area of any triangle, that is to say A abbreviation for the area, equals to the base of the triangle times the height to the base divided by 2. Okay, in the next step, we'll connect together lines O and B by a straight line. We'll connect together points O and B by a straight line. We will also connect together points O and C by a straight line. And we will also connect together by a straight line points O and A. Okay, so we will use the formula for the area of a triangle in order to find out the area of the green triangle So actually the area of the green triangle BOC will be equal to the base of the triangle. The base of the green triangle is 3 units. It is given us in the question, times the height to the base. As I already told you, the height must create 90 degrees with the base. Or in the green triangle, the height must create 90 degrees with the base side BC. So actually the radius creates 90 degrees with the base. For that reason, the radius is the height of the green triangle. So it is the base times the radius, that is the base times the height is the base, that is 3 units, times the height. The height is the radius of the circle divided by 2. So in total, the area of the green triangle equals to the base of the triangle, that is 3 units, times the height. The height is the radius of the circle divided by 2. So the area of the green triangle equals to the base, that is 3 units, times the height, that is the radius of the circle, divided by 2. 3 over 2 is 1.5. So I will write it down. So the area of the green triangle equals to 1.5 times the radius of the circle. And actually, in the same way, we can find the area of triangle AOC. Or the area of the yellow triangle, triangle AOC, the area of the yellow triangle, triangle AOC, will be equal to the base of that yellow triangle, that is 5 units. It is given us in the question, times the height. The height is the radius, as I already told you, because the radius creates 90 degrees with the base. So it is the base, that is 5 units, times the height, that is the radius, divided by 2. Or as you can see here, the area of the green triangle equals to the base, that is 5 units, times the radius, that is the height of the yellow triangle, divided by 2. 5 over 2 equals to 2.5, so I will write it down. So actually the area of the yellow triangle equals to 2.5 times the radius of the circle. And in the same way, we will calculate the area of triangle AOB. On the area of the orange triangle, triangle AOB, equals to the base of the orange triangle, that is actually 4 units. It is given us in the question. The base times the height to the base. The height is the radius, because the radius creates 90 degrees with the base AB, all divided by 2. So the area of the orange triangle is actually the base of the triangle, that is 4 units, times the height, that is the radius of the circle, divided by 2. 4 over 2 equals to 2, so I'll write it down. So the area of the orange triangle equals to 2 times the radius of the circle. So we can summarize and say that the area of the green triangle equals to 1.5 times the radius of the circle. The area of the yellow triangle equals to 2.5 times the radius of the circle, and the area of the orange triangle equals to 2 times the radius of the circle. Okay, and as you can see from the drawing, the area of the big triangle ABC equals to the sum of the areas of the yellow triangle plus the area of the green triangle plus the area of the orange triangle, because the big triangle ABC contains exactly those 3 triangles, the yellow triangle and the green triangle and the orange triangle. So the sum of the areas of those 3 triangles will be equal to the area of the big triangle ABC. So actually the area of triangle ABC equals to the area of the green triangle, that is actually 1.5 times the radius of the circle, plus the area of the yellow circle, that is actually 2.5 times the radius of the circle, plus the area of the orange triangle, that equals to 2 times the radius of the circle. Okay, so we actually created the equation that states that the area of the big triangle ABC equals to the sum of the areas of the green triangle plus the area of the yellow triangle plus the area of the orange triangle. Okay, so the area of the big triangle ABC equals to the area of the green triangle, that is 1.5 times the radius of the circle, plus the area of the yellow triangle, that is 2.5 times the radius of the circle, plus the area of the orange triangle, that equals to 2 times the radius of the circle. Okay, and we can summarize this side of the equation. 1.5 times the radius to 2.5 times the radius equal to 4 times the radius of the circle, and 4 times the radius of the circle plus 2 times the radius of the circle equals to 6 times the radius of the circle. Okay, so I will write it down. So actually the area of triangle ABC, the area of the big triangle ABC equals to 6 times the radius of the circle, because the sum of this side of the equation equals to 6 times the radius of the circle. So the area of the big triangle ABC equals to 6 times the radius of the circle. But we have already know that the area of triangle ABC equals to 6 units squared. It is given us in the question, so we can substitute the area of triangle ABC in equation number 1 by 6, because the area of triangle ABC equals to 6 units squared. Okay? So I substituted the area of triangle ABC by 6. We got in equation number 1 that 6 equals to 6 times the radius. We will divide equation number 1 by 6. So after we divided the equation number 1 by 6, we got that the radius of the circle equals to 1 unit, because 6 over 6 is 1. So the radius of this circle that enclosed in triangle ABC equals to 1 unit. Okay, so now I will summarize the lecture. Okay, we actually wanted to find out the radius of the circle, this circle that enclosed in triangle ABC, and we actually know that side AB of triangle ABC equals to 4 units, side BC of the triangle equals to 3 units, and side AC of triangle ABC equals to 5 units. And we also know that the area of triangle ABC equals to 6 units squared. And we want to find out the radius of the circle that enclosed in this triangle ABC. Okay, first of all, we defined the center of this circle as point O. Then we defined the touching point between side AB of the triangle and the circle as point N. Actually, side AB of the triangle is tangent to this circle at point N. And we also defined the touching point between side BC of the triangle and the circle at point M. We actually can say that the touching point between side BC of the triangle and the circle is at point M. And we also defined the touching point between side AC of the triangle and the circle as point P. And we can also say that side AC of the triangle is tangent to the circle at point P. Okay, so we actually have here 3 tangents to this circle: tangent AB, tangent BC, and tangent AC. Okay, and then we connected together by a straight line points O and N. Actually, line segment NO is the radius of this circle because it starts from the center of the circle and ends at point N. That is a point on the circle itself. For that reason, line segment NO is the radius of this circle. And we also connected together by a straight line points O and M. And actually, line segment MO is the radius of this circle because of the fact that it starts from the center of the circle and ends at point M, that is a point on the circle itself. And also we connected together by a straight line points O and P. And for the same reason, line segment OP is the radius of this circle because it starts from the center of the circle and ends at point P, that is a point on the circle itself. Actually, the definition of a radius of any circle is any line segment that is in the circle itself and starts from the center of the circle and ends at any point on the circle itself. It is defined as the radius of a circle. And as you can see, those 3 line segments, line segment NO, line segment OP, and line segment MO, satisfy the definition of a radius of a circle. For that reason, those 3 line segments are the radiuses of this circle. Okay, and actually we have rule number 1 that states that in any circle, a radius and the tangent to that radius are perpendicular to each other. So if we have radius that we called R and we have tangent that we called T, then the radius is perpendicular to its tangent. That is to say, this angle is 90 degrees and this angle equals to 90 degrees also. So in any circle, a radius is perpendicular to its tangent. Actually, we can implement this rule in our circle because we have 3 radiuses and 3 tangents to those radiuses. For that reason, according to rule number 1, the radiuses are perpendicular to its tangent. That is to say, line segment NO, that is the radius of this circle, is perpendicular to its tangent AB. That is to say, angle ONA equals to 90 degrees, and also angle ONB equals to 90 degrees. And we can also say that line segment MO, that is the radius of this circle, is perpendicular to its tangent BC according to rule number 1. That is to say, angle OMB equals to 90 degrees, and also angle OMC equals to 90 degrees. And for the same reason, line segment OP, that is the radius of this circle, is perpendicular to its tangent AC. And according to rule number 1, actually, that is to say, angle OPA equals to 90 degrees, and also angle OPC equals to 90 degrees. Okay, and according to the general formula for the area of any triangle, we know that the area of any triangle equals to the base of the triangle times the height to the base divided by 2. So instead of the area of the triangle, we can write down capital A, that is the abbreviation for area. So A equals to the base of the triangle times the height to the base divided by 2. And you should remember that the height of the triangle must create 90 degrees with its base. Okay, so we can implement this rule in our triangles inside the big triangle. Actually, before that, we connected together points O and B by a straight line. We connected also together points O and C by a straight line. We connected also together points O and A by a straight line. And the area of the green triangle equals to the base of the triangle, that is 3 units, times the height, that is the radius of this circle, because the radius creates 90 degrees with its base. For that reason, the radius is the height of the green triangle, so it is the area of the green triangle equals to 3 units times the radius divided by 2. Or in total, the area of the green triangle equals to 1.5 times the radius. In the same way, we calculated the area of the yellow triangle. The area of the yellow triangle equals to the base of the yellow triangle, that is 5 units, times the height. That is actually the radius of the circle divided by 2. So the area of the yellow triangle equals to 2.5 times the radius of the circle. And in the same way, we calculated the area of the orange triangle. The area of the orange triangle equals to the base of the orange triangle, that equals to 4 units times the height. The height is the radius of the circle because it creates 90 degrees with the base. So in total, the area of the orange triangle equals to 4 units times the radius divided by 2. Or the area of the orange triangle equals to 2 times the radius of the circle. So we calculated actually the areas of the orange triangle, that equals to 1.5 times the radius of the circle, and we calculated the area of the yellow triangle, that is 2.5 times the radius of the circle, and we also calculated the area of the orange triangle, that is 2 times the radius of the circle. Okay, and we actually know that the area of the big triangle ABC equals to the sum of the areas of the yellow triangle plus the area of the green triangle plus the area of the orange triangle. So we actually created equation number 1 that states that the area of the big triangle ABC equals to the sum of the areas of the green triangle, that is 1.5 times the radius, plus the area of the yellow triangle, that equals to 2.5 times the radius, plus the area of the orange triangle that equals to 2 times the radius of the circle. So in total the area of the big triangle ABC equals to the sum of the areas of the green triangle plus the area of the yellow triangle plus the area of the orange triangle. And the sum of this side of the equation equals to 6 times the radius, so the area of triangle ABC equals to 6 times the radius of the circle. So, but we have already know that the area of triangle ABC is 6 units. It is given us in the question. The area of triangle ABC equals to 6 units squared. So we can substitute the area of triangle ABC by 6 because the area of triangle ABC equals to 6 units squared. So we substituted the area of triangle ABC by 6, and we got that 6 equals to 6 times the radius of the circle. We divided the question number 1 by 6, and we got that the radius of the circle equals to 1 unit. Okay, the radius of the circle enclosed in triangle ABC equals to 1 unit. Okay, thank you very much.